Hello, this is G. Ramesh Kalyan, Assistant Professor, Department of Computer Science and Engineering, SNS College of Technology. The course name is 19 CST 302 Neural Networks and Deep Learning. And the topic is Rectified Linear Unit Applications. So, so we saw previously what is a rectified linear unit, that is RELU. So this is a widely used activation function in the neural networks, and it's a simple piecewise linear function that outputs the input directly if it is positive, and otherwise it outputs as zero. So it is a simple activation function that uses a linear function. So with that linear function, it outputs the input directly if it is a positive one. So if the given integer or a given value is a positive one, it directly outputs the given value. And I mean, if the value is a non-positive one, then it outputs the value as 0. So mathematically, ReLU, that is rectified linear unit, is defined as f of x is equal to max of 0 comma x, where x is the input to the function. So ReLU has become popular mainly to simplicity and efficient of the training deep efficient in training deep neural networks. So it plays an important role in training the deep neural networks. So we'll see the applications of ReLU, that is rectified linear unit. So firstly, rectified linear unit activation functions find applications across all the domains. So mostly it covers various domains, especially in the field of deep learning and neural networks. So first one is image classification. So this activation functions are frequently used in convolution neural networks for image classification process that rely on extraction of hierarchical features from images and introduce the non-linearity to the learn complex patterns within the inner value. So next application is object detection. So in these tasks as object detection or semantic segmentation, the model needs to identify the localized objects within an image. Then the rectified linear unit activation functions are commonly used in the convolution layers of the architectures like Faster or CNN, YOLO. We have a version, even a improved version of this, that is YOLO V8 or a mask or NN. So this is all about the object detection. The next one is natural language processing. So in this, the rectified linear unit activation function is employed in the neural networks used for the NLP tasks such as text and sentimental analysis, machine translation, and other language generation processes. So the architectures like recurrent neural networks (RNNs) are being used in it. And next application is the speech recognition. So in speech recognition systems, the models need to understand and transcribe the spoken language. So these activation functions can be found in the layers of deep learning architectures like recurrent neural networks RNNs and convolution neural networks CNNs or their combinations. So an example is CTC based models. So in simple words, uh, that is a rectified linear unit. So this activation function initially need to understand the language. Initially need to understand the language. Only when the activation function could understand the language, it could translate or it could transcribe the language to a sentence or a particular as per its use. So this is done using the recurrent neural networks or convolution neural networks or the combination of both the networks, that is recurrent neural networks and the convolution neural networks. Then the generative adversarial network, so GANs. GANs is one of the improved technology. So generative technology is improving daily. So mainly in the field of deep learning, it has been used for image generation or image sample generation, and many applications is widely used. Next one is recommendation systems. So this predict the user's preferences or recommended items based on the previous history. And anomaly detection is the finding of the errors or errors or the outliers in the data. Thank you.